Okay, let's get started. Today we're going to talk about code quality. So we're going to cover a number of topics, including code formatters, linters, testing, pre-commit hooks, continuous integration, and command runners. And then if we have time at the end of lecture as a bonus topic, we'll cover regular expressions, which is a cross-cutting topic that has applications in a number of domains, including in code quality. Like some tools have parameters that are controllable using regular expressions. So we'll cover all of those topics today. And we're going to be talking about code quality concepts in today's lecture, but many of the tools we are going to present in today's lecture will be language specific. And the reason for that is that a lot of these tools kind of have to be language specific because they need semantic understanding of the language they're working on. But again, the focus is on the concepts, not the specific tools we are presenting. And the concepts are near universal. So for any of the concepts we're talking about, like linting or testing, you will find tools or libraries applicable to the programming language that you use. And for this, for today's lecture, I'm going to basically, as a case study, be working on this little library we wrote called minilib, which is this single file Python library with a bunch of random utility functions that are not actually that useful, but are what we need for the purpose of demonstrating the various things we want to talk about in today's class. So let's start off talking about code formatting. So code auto formatters automatically prettify surface syntax in your programs. And the reason for using these tools is that you can use the tool to automate the more mundane details of writing code and keeping it looking clean, while you can spend your brain power thinking about deeper and more challenging problems. So if we look at this code I have open on the left, if you look closely, you'll notice there's some little formatting inconsistencies and things that are not so nice. Like for example, in Python, you can have strings delimited either by double quotes or by single quotes, and I'm inconsistent here. So like this line of code has double quoted strings, this line of code has single quoted strings. I have other little weirdness here, like I have this binary operator here where I have spaces in between here, but I forgot to add a space here, and maybe there's some other issues in here I don't remember that the auto formatter will catch when I run it. And so auto formatters will either check to see if the format complies with the standard, or many of them can actually fix your code so it complies with the standard, so it's a job that you don't need to do anymore as a human. And there are some tools out there that are that support multiple programming languages. There's some tools out there that are highly configurable, so you can say to the tool, like, oh, I prefer my Python strings with single quotes rather than double quotes, and oh, I actually want no spaces in between my binary operators and stuff like that. And then on the other hand, there's some code formatter tools that have very limited configurability. And the reason for that is to reduce bike shedding. Like programmers shouldn't be spending their time debating whether single quoted or double quoted strings in Python look better. They should spend their time on more important tasks. And so the code formatter tools just try to set a standard and everybody follows the standard, and you don't need to worry about anything. Also, for some code formatters, you can set up IDE integration with your formatter. So when you save your code, it'll automatically get formatted. That I'm not going to demonstrate today. So yeah, here I pointed out a couple issues with this code where it's not so nice. And here I'm going to go and run the auto formatter I have set up for this project. Now I'm using a Python package, a project manager called Hatch, and I've configured it so the hatch fmt-f command runs the formatter. You don't need to worry about the details of the configuration, and I think we'll just open source this repository if you want to look at the details of this particular one. But again, focus on the concepts. So if I do hatch format -f to run the code formatter, and if I run --check, it will check to see if the code is compliant with the formatting standards and show me what needs to change. So here I'm going to zoom in on this window, and we can see it shows a diff. So it's showing like, okay, we want a little bit more spacing between our function definitions. And then there are a bunch of little issues here, like the ones I pointed out, like it's fixing this single quoted string to be a double quoted string, and it's adding a bit more space between these binary operators. And I purposely kept this diff pretty small. Didn't want to introduce just like a ton of formatting weirdness, but if we go and do other things, like, okay, I add some more spaces between the parameters here, like maybe I have an like unnecessary new line in a weird spot, like it will fix that sort of, your code does need to parse though. So it will fix some of these weird things for you. So if I tweak it in that way, it'll say like, oh, I want to compress the spaces here. So these tools can be run often in a check-only mode, or they can be run in a mode where they actually make the fixes to your code. And so switching back to this hatch fmt-f command without the --check. And when I run that, the tool says, okay, one file has been reformatted. And if I reload that file in my editor, I'll see that all the changes it said it was going to make have indeed been made in the code. There's one other tool and standard I want to talk about in the context of formatting. There's this thing called editor config, which is a file format and class of IDE plugins that help developers maintain consistent coding standards across different IDEs. So like if you're using Vim and your friend is using VS Code and your other friend is using Cursor and you're all working on the same code base, little things that might be mismatched between the different people's configuration can lead to some annoyance. For example, like you might be using different levels of indentation in your code. So like in my Python code, I'm using 4 spaces for indentation. So every time I press tab, things go in by 4 spaces. But you could totally, like it's legal to indent your Python code like this. And somebody might have their IDE configured that way. And so if I open up my editor config file here, it's in the root directory of the Git repository. It has some basic settings like, do I want to end my files with a new line character? What character should I use for spaces? Do I want tabs or spaces? Should the editor automatically delete trailing white space at the end of the line? So I've added a bunch of white space characters here. And when I save the file, it just gets rid of them. And then you can do things like on a per file type basis or per file name basis, configure little details like what's the indentation size you're using. And so it's this little thing that helps keep things consistent across different IDEs. And so like we use editor config in our missing semester repo, for example. So that's a brief introduction to code formatters. It's a pretty simple concept. I don't have too much more to say on it unless people have questions. But just, a really handy tool that I recommend you use in every single project of yours. Cool. So let's see here. Let me actually go ahead and commit these changes. So I can do like git commit -a fix formatting, just so we can slowly improve our code base over time as we're live coding in this lecture. So the next topic I want to talk about is linters. So there's this term linters, and linters run static analysis on your code. So it's static analysis as opposed to dynamic analysis in the sense that the linters analyze your code without actually running it, but it is a semantic analysis of your code. So you can think of it as going a little bit deeper than these code auto formatters, which just look at surface syntax. And what linters try to do is find anti-patterns and potential issues in your code. And the level of depth of analysis varies between tools, but generally these things can catch a lot of things before they become like bugs that you run into in practice. And linters generally come equipped with a list of linter rules. And these are presets that can usually be configured on a project level basis if you want to. And then some linter rules, these bad code patterns that these tools look for, can sometimes have false positives. So many linters also support disabling linter rules on a per file or per line basis. And a couple of the good things to know, generally good linters will have help or documentation that when it complains about aspects of your code, it'll tell you like why what pattern it's looking for, why that particular code pattern is bad and should be avoided, and might actually suggest a better alternative for the code pattern. And some linters can actually fix some issues for you. The tricky thing with linters, though, is it's going beyond just a syntactic analysis. It's a semantic analysis, and sometimes these static analyses are not perfect. And so some linter rules come with safe fixes, where it's always safe to apply the fix to your code. And in other times, it can find things that are like potentially problematic things in your code, but it's really hard to write a safe transformation to your code that will like preserve semantics and won't break anything. So sometimes linter errors will have to just be fixed by the human programmer working on the code base. So let's look at a demonstration of a linter running on this code base. So let me run. So again, in my project, I'm using the Hatch Project Manager. I've set up this command to run a linter configured with a bunch of linter rules for my Python code. And here I'm running it with --check, so it'll just flag potential issues with my code. And then later we'll see what it can auto-fix versus what it can't. And so we can see here the summary at the bottom. Let me again zoom into this window. It says found 7 errors, and the linter points out, oh, 3 of these are actually fixable with the --fix option. And there's also this --unsafe fixes option if you're feeling dangerous. And so we can see some of the things it complains about. We can see that these are, like kind of lightweight semantic checks on our code. So we're seeing like, okay, this is saying I have some code that does an import star, and that's problematic because it makes other static analysis more difficult, among other things. So that's an anti-pattern. I have an unsorted block of imports. So just for cleanliness, it's nice to have Python imports in sorted order. I'm importing a module that I'm actually not using. So here I see, okay, OS imported but not used, and so on. So let's go through some of these and fix them. And as a starting point, actually, let's call the linter without the -- check, so it can actually automatically fix some of the issues. So actually, let me call it with the -- check and walk you through the issues it's going to automatically fix. So this one has a star on it. The way this linter is set up, it'll mark with a star the things that can be auto-fixed. So yeah, like sorting things, like sorting imports is a safe operation to auto-fix this. It'll automatically remove this unused import. And then another little code pattern it points out is not great is here I have this if return and then an else if, but you actually don't need an else if because in this branch you're returning in the if case. So this can actually just be a regular old if without being an else if. So that's another pattern that they recommend you don't use in your code. So if I run the linter with fix mode on and I reload my file, I'll see that some of these things have been changed. So my if else if changes to an if. The unused import's gone, and I think maybe some other minor fixes were made. But now I can take a look at the things that the linter was not able to auto-fix for us. So let's start with the first one. I have this import star here. I've done that so that in this particular library, I can do from minilib import whatever, and it will import the names from this utils submodule. So I actually want my code to behave that way. I mean, this is not a great programming practice, but for demonstration purposes, say I want to keep things that way. I can actually say like, okay, so this code, the linter was complaining about, and it's giving this like F403 error. And so I can say no QA F403, and this turns off the linter for that particular line. So if I run the linter again, now I don't see that particular error anymore. And so this is generally how these tools are used, like especially for larger projects. Like you will want to keep a lot of static analyses enabled because they do help catch potential bugs and bad patterns in your code. But the analyses aren't perfect, and so you might have to add these no QA sort of annotations in various parts of your code. So let's keep going and fix the rest of the linter errors. So I also want to demonstrate how the linters can actually teach you about how to write better code. And so let's take a look at, here, I'll zoom in, and let's take a look at this first, the second issue here. So I have this code that raises a value error, and I have a string literal in there, divide by 0. And the linter says, EM101, exception must not use a string literal assigned to a variable first. So that's telling us what to do, and we could just go and fix the thing. But if we want to learn about why this is bad, we can just Google this. And for this particular linter, I'm using the rough linter under the hood. And they have extensive documentation which explains every single linter rule. And then there's a what it does, so you know what code pattern it's looking for, and then the why it's bad, so you can actually learn. So like here it's saying, when you use a raise statement in Python code, it shows you a backtrace. So it shows you like what lines of code were executed that led to that exception. And then it also shows you the error message down below. And so if you use a string literal in the same line as this raise, you'll end up seeing the message twice. So it's like kind of redundant and takes up space on your screen. And they even have a concrete example here. So if you have Python code that says raise runtime error, some value is incorrect, you'll see this kind of a backtrace where it'll show this line of code, this raise, but then it'll also show the error class and the error message here. So this appears twice, right? And so that's the bad pattern. Like that's why we want to avoid this pattern. And then the linter documentation tells us like what's the right way to do this. Instead, you assign the string to a variable. So you just add one extra line of code, bind to a variable first, and now you have much nicer error messages where you see raise runtime error message without the redundant string in there. Right, so simple fix. So let's go ahead and make that fix to our code. And when I save this and rerun the linter, now it's complaining about only one more thing. So it's saying that I have this code down here that calls, it uses the Python subprocess module and calls the cat command, but it's being spawned with shell equals true. So instead of calling the cat program directly, this actually calls like Z-shell on my computer, and that parses the string and executes it. And this is a bit dangerous. There are potential security issues here. And we won't talk about why this is a security issue. In TLDR, like if this file name contains certain funny characters, like if there's a semicolon followed by something, then the thing after the semicolon will be interpreted as code and run by the shell. Anyway, like, so this is a bad pattern you should avoid in your code. And this is another thing that this linter rule catches. Let's actually go ahead and ignore this one for a moment. So I'm going to add that no QA line, no QA S602. And then when I rerun this linter, it passes. So now, instead of returning a non-zero exit code, I see that when I run the linter, it just says all checks passed and returns 0. So we're all good. And the reason I want, like in practice, you'd probably just like fix this. This is not a good code pattern to follow. But the reason I wanted to suppress this for the moment was that I wanted to introduce one more tool to you. So when you get linter set up for your projects, you'll probably pick some popular one for the programming language you're using, and it'll come with a large list of built-in linter rules. Like if we go to here and look up like rough linter rules, there'll be hundreds and hundreds. Yeah, like rough has 800 different code patterns it's looking for in your code, and there's this huge list that'll explain them all to you. So this is great for getting started. But sometimes for specific projects, you might want to have project-specific linter rules. Like maybe in a particular project you're working on, you say like, oh, we don't want to use the Python pickle module because it can be used in insecure ways. Or, oh, we don't want code that uses the exec function in Python, or things like that. And for such situations, it's handy to be able to write your own linter rules. Sometimes the main linter tool you're using will be configurable, but another tool that can come in handy is something called semgrep, which stands for semantic grep. So recall that we introduced the grep tool, I think in lecture 1, and grep searches text or code for patterns, for string patterns. So semgrep is conceptually similar, but it actually parses the syntax tree of the programming language you're using and searches at that level. And so it can actually go like a little bit deeper than a very like character level syntactic search can go. And so as a concrete example, let's say that we want to, let's say that our linter didn't have a built-in check for this subprocess.checkOutput with shell equals true. So we could imagine writing some grep command like, actually maybe I'm going to use a grep alternative called ag, but we can do something like search for subprocess.checkOutput, open parentheses, and then like dot star, which in regex is some number of characters, comma, shell equals true, and then I can search for this, and it indeed matches this line. It says that this is found, right? So then I could set up a little script related to my project where it would search for these kinds of things and help catch bad patterns in my code, right? The problem is that this regular expression here, for example, is a little bit fragile. Like you, in this particular case, this subprocess.checkOutput command takes additional keyword arguments. So I could do like, add some more code. And then this will actually, this is a capture group. It's not looking for literal open and close parentheses. But when I fix that, yeah, this no longer matches. So if I undo this change to my code, this matches. But if I make a slight tweak to the code, it doesn't match anymore. And so you could put in a bunch of effort into trying to write a regex pattern that works, but then like little things will break it. Like another thing that'll break it actually is just adding a new line here. So let me zoom into this window so you can see where my line breaks are. Like you could totally format your Python code like this, right? And in this case, I think the auto formatter will change it back. But here, again, when I do this grep or ag command, it doesn't match this anymore because these are now broken across lines. And so you can kind of play whack-a-mole and like try to write a whole bunch of regex patterns that look for the thing you want. But instead, you can use the semgrep tool. And so semgrep is language aware. So you can say, I want to search Python programs and look for the semgrep pattern. I'm looking for subprocess.checkCall or checkOutput here. And I want to find all instances where this is called with like some arguments, then a shell equals true, and then some more arguments. And when I run this, it does find this instance of this code, even though I have this line break in here. And if I add something like this, it will still match that code. So semgrep is a useful tool for writing your own lightweight analyses in order to augment your linter in your project. Any questions about that? Cool. So let's go ahead and git commit these changes just to get them out of the way. Fix linter errors. And let me rerun my, Oh yeah, this no QA thing doesn't work anymore because I broke this across lines. Let me fix this. S602. And rerun my formatter and linter and commit that. Okay. Yeah, any questions about linting before we move on to the next topic? Great, we're well on our way to having high quality code. So the next topic we're going to talk about is software testing. Now, testing is a really deep topic, and you could teach like multiple lectures on how to write good tests. So I'm just going to introduce you to some of the high-level concepts and then encourage you to explore more on your own time. So software testing is a standard technique for increasing the confidence in the code you've written. And the very high-level idea is that you write some code, and then you write some more code that exercises the code you just wrote and evaluates whether it behaves in ways that you expect. And the idea is that you can write your code, write these tests, and then the tests are useful long-term, so you can keep running the tests as you evolve your code to make sure like nothing breaks in your code or things like that. And then there are many different approaches to writing tests, and tests can be written at different levels of granularity. So there are unit tests, so you can test, say, individual functions in your program. So you can say, like, oh, FizzBuzz should behave in this way, and LeftPad should behave in this way, and so on. There are integration tests that can test for interaction between different modules or services in your project. And then there are functional tests, which are more end-to-end, like does the software satisfy user requirements? You can evaluate entire end-to-end scenarios there. So you can think of testing at different levels of granularity. And then there are different testing approaches too. Like one popular approach to developing software is something called test-driven development, where instead of writing an implementation first and then writing tests for it later, you'll actually flip the script. And you'll have an idea for something you want to implement, have a specification in your mind, and basically express that specification or a partial specification through tests. Like, this function I'm going to write should behave in this way. And then you can go ahead and write the implementation and then run the test to confirm that the implementation indeed satisfies the spec. Yes?
Wait, so there were unit tests, which is testing individual functions, and then what was and then there was end-to-end testing, which is testing the whole project, and then what was the...
Yeah, so there are unit tests, integration tests, functional tests, and this is all in the lecture notes. And also people have come up with different terminologies to describe different testing approaches that are not in the lecture notes as well. So this is a pretty deep field. So let's look at some examples of software tests. And for those of you who are looking closely at the code on the left, you might have identified some bugs in this code already. But let's think about this more from the testing standpoint and try writing some tests for these functions in order to help us catch the bugs in the code. And so let's start out with writing tests for FizzBuzz. I think we've talked about FizzBuzz before, but it's this. I've basically turned FizzBuzz into a function here, and here's the specification in English language. For a given integer I want to return fizz for multiples of 3, buzz for multiples of 5, and FizzBuzz for multiples of both 3 and 5. And if none of those hold, then I want to return just the number itself. And so I am going to write some tests for this. So I'm going to split the screen so you can see the FizzBuzz implementation up here. And then here I'm going to create a new file, test fizzbuzz.py. The specifics of exactly how you set up your testing framework and like where you put your tests and all that is dependent on the programming language you use and also on the particular testing framework. Like here I'm using Python and PyTest. But yeah, when you get to this point in your own project, you should just look up like how to set up testing for whatever language you're using. Like what Java testing framework should you use? In the PyTest framework that I'm using, what tests look like are they go in the special location, they start with test underscore, and they're just plain old Python functions that take no arguments, return nothing, and just contain a bunch of assert statements. And then the testing framework will run all these functions when I ask it to run. So I can do something like assert FizzBuzz of 3 is equal to fizz. So I can write that test, and I'm going to run hatch test here to run all my tests. Ooh, where is this file? Oh, I am not at the top level of my project. Here, yeah, so I'm gonna zoom into this window and rerun that so it looks a little bit better. Yeah, so I just ran my singular test where I asserted that fizzbuzz of 3 was equal to fizz. And then here it says name error, name fizzbuzz not defined. So this also illustrates that you can actually have a bug in your tests themselves. I forgot to import my module here. So I'm going to do from minilib import fizzbuzz. And then let me rerun my tests. And then I see it's all green. It says 1 test passed, right? And so the idea is that you can write a bunch of tests, hopefully going a little bit deeper than these very simple programs and tests I've written here. And that might help you catch some bugs in your program. So what's another test that you might want? Maybe like fizzbuzz of 30 should be the string fizzbuzz, right? And then when I go ahead and run the test there, it'll complain, whoops, here. It'll say, okay, this test failed, the test fizzbuzz2 failed, assertion error, assert fizz equals fizzbuzz. So the thing on the left here is actually returning just fizz when I wanted fizzbuzz, right? So based on this failure, now I can go and analyze my code and try to figure out, like, okay, for this concrete input, why did it fail to give me this concrete output I was expecting? And then I can go ahead and notice, like, oh, maybe this test here should have been at the top. So I can go ahead and fix that, rerun my code, and now both of these tests pass. So great. Any questions so far? So a couple other topics I want to cover related to tests. One question you might have is, how do you measure how good your tests are? Like, how do you know that you've done a good job? And in part, it's kind of hard for somebody to like write a program to tell you how good your tests are, because it requires like creativity. You want to exercise your code in the right way. And testing is a little bit of an art that you'll get better at over time. But there are some tools that can help you. So there's this one metric called code coverage, which looks at of your implementation, like which of the lines of code are actually exercised by the tests. Like if we look at these tests, for example, like actually, let me just go ahead and run my code coverage tool and show you what that looks like. So I'm going to do hatch test-c. So I've set this up so it computes code coverage when it's running the tests. And it tells me, OK, in this utils.py program, I have 18 statements, and I actually missed 9. So I only have 50% coverage. There's a bunch of untested code in this implementation. And when you use code coverage tools, you can actually get a nicer report than this. In my setup, I can do hatch run coverage HTML. And this will generate an HTML formatted report that I can open in my web browser to help me better understand where I need to focus when writing tests. So this is that code coverage interface just running from that local file in my web browser. And if I open up this utils.py thing here, I can see like, OK, I had that I equals 30 test case for fizzbuzz. And so this is covered. It's in white or with no background. This was also covered. That was the first test I wrote. But these two cases actually aren't covered by my tests. And also this stuff down here is not covered by my tests. All right, so I can go back and say, like, OK, I realize I'm missing some tests, so let me improve my coverage. I'm going to write a test fizzbuzz3 function that does assert fizzbuzz of, let's do like 99. So what should this be? That should be fizz, right? And maybe I can do one that's just actually, I'll just leave it at that. I can rerun my tests with coverage. I get my report, and then I can do, oh wait, sorry, that was not useful because we were already testing 3. We want to hit this line of code, so let's do like 95 here, and this should be buzz. So when I rerun my tests with coverage, now I see that the coverage has gone up from 50% to 61%, and I can generate the HTML coverage report and open it up in my browser again. And now I see that that line is indeed covered. So that's code coverage. I think it's a pretty decent metric to use. It's also a decent metric to look at when you're trying to assess the quality of some open source project that you find online. Like if they're doing a good job and running all these code quality tools and things like that, they will probably care to some degree about code coverage. And if you see a project with very low code coverage, then like, yeah, you don't know how high quality the code might be. One more cool topic I want to, yeah.
This might be too big for this quick question, but is there an easy way of saying with AI, how would I need to change what I'm doing in order to get more code coverage of what I'm testing?
Yeah, that's a great question. So
Just make it better, like, make it cover more and suggest something for me? How would you do all that?
yeah, so the question is, can you use AI to help you improve code coverage? And the answer is absolutely. That's one of the exercises we recommend for this lecture. You can set things up in a kind of closed loop way where you make sure your AI agent is able to run your tests and run it with coverage and generate a report that it can look at, like either in that HTML format or like with the tool I'm using, it can generate an XML format report, which will be a little bit more dense and probably better to give to your LLM. And then you can just tell it, like, improve my coverage till you get to 100%. And like these AI coding agents are actually pretty decent at writing tests for you.
Could you show us how to do that quickly? Or maybe that's a homework assignment, but I just...
Yeah, I want to make sure I cover the other topics. I think that description should be enough. And if we have time at the end of the lecture, remind me and we can cover it. But yeah, AI agents are pretty good at writing tests. One thing to keep in mind, though, like code coverage isn't a perfect metric, and also like AI isn't perfect at writing tests. And like it's a little bit hard to demonstrate with code like this, which is so simple. But for more sophisticated code, it's possible to write tests that like achieve high coverage, but are not actually that meaningful. Like they're not really thoroughly exercising your program, and you can have like software with bugs, which passes all the tests, right? And so like I have seen people who've done AI generated testing, especially for things like front end, where I've seen repositories with 100% code coverage and the tests are like almost completely useless. So just something to be aware of there. Like it can be good, but it can sometimes not be good.
I would say test all the different cases, not just code coverage, but test the functionality in a way.
Yeah, so the question is, can you guide the AI more and say things like test the functionality? I mean, yeah, yes, you can. And AI can be pretty decent at writing tests. I'm just saying that it's not like necessarily perfect. And like you do want to scrutinize its output. And sometimes you might need to give it more input than just like write tests for my program. You might need to guide it, and that'll let the AI produce better tests. Cool. So while I was coding, has anybody noticed the bug in this this left pad function yet? So anyway, this function is a bug, but it's a little bit hard to spot because I've written this kind of tricky way of implementing this left pad. The spec of left pad is given a string. I want to pad it with spaces on the left so that its minimum string length is I. It's useful for like table formatting and stuff like that in command line programs. So I want to introduce you to another type of, another approach to testing, something that's called property-based testing. And the idea with property-based testing is that instead of writing kind of discrete test cases like this, like, oh, with this concrete input, does my program produce this concrete output? You can instead write down properties that your function should have, and the testing library can actually test those properties over a bunch of different inputs that are automatically generated. And so this gets you a little bit closer to writing down a formal specification for your program. And they're generally not complete specifications, but you can write down partial specifications of properties that should hold. So let's demonstrate that in the context of this left pad thing. And I'll create a new file for that and do from minilib import left pad. And then for this property-based testing, I'm using a library in Python called Hypothesis. This approach was originally invented and popularized by the Haskell Quick Check library. But now there are libraries in a bunch of programming languages that support this kind of testing. So like, can anybody tell me, like, what's a property, what's a mathematical property that this left pad function should have? And think with your math hat on. Like, I want a statement of the form, like, for all strings and for all integers, property. Yes?
If we generate a bunch of random integers and then multiply them by, and then we multiply them by, and then we run them through some algorithm to make sure that they're not divisible by 5, and then we multiply them by 3, we should always get buzz.
OK, so I'm asking about the left pad function. So I want some property that's of the form like for all s string, for all I int, something. And that something should be a statement about the left pad function.
The length of left pad should be equal to I plus the length of string.
Yeah, great, very close. The spec for left pad here is that the minimum length of the output is I. If you have a string of length 5 and I is 5, then the output is actually just length 5. But yeah, that's a reasonable property to write down. So in Hypothesis, I can do this like this. I can say I want like test left pad 1. And then this takes in a string and an integer. as arguments that are supplied by the testing framework, and then I can write down the property in here. It's a function of, like, for all s, for all I can say, okay, the length of left padding s with I should be at least I, right? Like if I take a string and I pad it to a length of I, like the result should be at least length I. If I start with something bigger, then it's okay if the thing is bigger, but it should never be less than I, right? So I can write down this property, and then with hypothesis, you can set this up with this code. And then, yeah, this will vary by property-based testing library that you use. And then important to keep in mind that here, hypothesis is not doing like a mathematical proof of this property. There are some techniques for doing that sort of very deep reasoning about your code. But here, what it's doing is just generating a bunch of random inputs and looking and seeing if the property holds. So you do need to parameterize this and give it a little bit of help. Like, OK, for S, I want you to consider text up to length 20. And for I want you to consider numbers between 0 and 50. So a little bit of human intuition required there. And so I can do a hatch test. And I see that this indeed passes this test. So fantastic. But let's go ahead and write another test. Another property that a padding function should have is that if you take a string and you pad it, the original string should be contained in the result, right? That's like another reasonable property that you might want. So S should be contained in left pad of SI. And when I run this, this works. What was the bug? What was the bug I created at like 2 a.m. last night that I was trying to reproduce? In any case, in the interest of time, I'm not going to try to remember that. Let's just go and break this implementation. Like, let's say that we left pad by taking the padding length and multiplying it by I, and then adding in S. So this is like clearly wrong, right? Like if we start with a string of length 5 and we want to make the padding 7, we don't add 7 spaces to the left of the string. But I'm just going to go ahead and break it in this way, just so I can demonstrate that this property-based testing approach catches it. Whoa, what? Oh yeah, actually, this still sounded, okay, I guess this demonstrates a different aspect of property-based testing, which is this is a partial specification. It's checking to see that certain properties hold, but actually this broken implementation still satisfies these properties. Let's do something like this. Like, okay, suppose I just forgot to implement this and return S. This still holds, right? Let's say that I take a substring of this string. Now, like, I'm doing something insane here. What is going on? Live demos. Yeah, like this property should not hold anymore for the program. All right. We have. Are you running the process at all? Huh? Are you running the process at all? Yeah. I'm running all the tests. So it is running this test left pad 1. Oh, wait. I am missing asserts. That is what is going on. So it was just like evaluating that expression, and it was either true or false, and then it was continuing on to the next line. OK, I think this actually did fail some of the tests. So let's restore that. And now we see, OK, so this implementation I had before, which actually I think will pass this first property, like this will always hold for this broken code, but the second property that the string is contained in the left padded version actually doesn't hold. And an example where that doesn't hold, so the cool thing with property-based testing is it'll try this for a bunch of random inputs, and then we'll see, OK, this gives me a concrete counterexample where the property does not hold, where here, say, S is the string 0, 0, and I is 1. And then armed with this concrete counterexample, I can go and debug the code. And yeah, we can go ahead and fix this if we want to. But I think in the interest of time, we won't fix it. And if you were so inclined, you can go and try to fix the code so it passes these property-based tests and doesn't fail this one anymore. So any questions about property-based testing? Great. And then moving right along, another useful tool that you can use to enforce code quality across everybody contributing to your project is something called pre-commit hooks. And this is a mechanism by which you can set up Git so that it runs a script before any Git commit happens. And so in this project, we've already set up, let me just get rid of this. Oh yeah, you can leave this as is. We've already set up a formatter and linter, and we have a mechanism to run tests and so on. And so I have in this file pre-commit config.yaml, I'm using a program called pre-commit that's linked in the lecture notes, but there's also this general concept of pre-commit hooks. In this file, I've been configuring this pre-commit command so it runs hatch format -- check before I make any commits. And then a developer who's working on this repo just one time has to do pre-commit install, and then it says, okay, it's installed the pre-commit hooks in the Git directory. And then after this, if there's any errors in the code, like let's just go and like badly format this, if I try to do git commit, before it pops up the editor and lets me write my commit message, it runs all the pre-commit hooks. So in this case, it's run this hatch format -- check, which returned a non-zero exit code, and then that's interpreted by pre-commit and by Git as like, oh, something went wrong, and it's showing up, all this debug output. And until I fix these issues, I cannot proceed with the commit. So it's a good way to enforce code quality across all the people working on your repo, because otherwise it's easy to forget to run like hatch format before you commit changes. Was there a question? No.
Right, so a pre-commit hook in Git is a list of tests that you can put into your repo, and you're forced to pass all of them before performing a commit.
Yeah, exactly. Pre-commit hooks are checks that run before every commit. And if the check fails, then Git will not let you commit. There's a flag you can pass to skip the pre-commit checks if you really need to. But it's a good way to enforce consistency across all developers. OK, so far we've talked about running all these checks on our local machine. Now we're going to talk about continuous integration services. So CI services like GitHub Actions, which maybe you've heard of, are often paired with repository hosting services like GitHub. And the idea is that you can run software on a remote server there whenever certain things happen. So you can set these things up so that whenever you push changes to your code, or whenever somebody makes a pull request, or even on a schedule, like every Monday at 9 a.m., it'll run some code for you. And then you can go and put a whole bunch of useful code, or like configure the CI service to do things like run the format checker and run the, we haven't talked about type checking yet, but for statically typed languages, you can run the type checker as another type of code quality check. You can run your tests. Another useful thing you can do is that in these CI services, since it's a remote machine that's happy to run a long-running job, you can run what's called a matrix of tests. So far, when we were doing hatch test on my computer, it was running these tests just like on Mac OS using Python like 3.10 here. But for more sophisticated projects that have like a lot of complicated dependencies and things like that, you might want to run the tests across a variety of platforms. Like you want to run them on Windows and Linux and Mac OS, and you want to run them for all the different Python versions like 3.7 all the way through to 3.14. And CI services let you easily configure things so that you can run this whole matrix of tests, like this Cartesian product across all the different parameters you want to vary, and all in parallel, so it runs pretty fast. And then since this is run in a centralized place, anybody can look at the CI results, and it's all very convenient. And we don't have time to talk about the details of exactly how to configure GitHub Actions in today's lecture. But as a general strategy, like for all of this code quality stuff, like even I don't memorize how to use GitHub Actions. Like whenever I need to use it, I'll go look up the documentation or like find an example from a different repo that's similar and just massage it to fit my needs. Or ask your coding agent to do it. Those things are really good at doing that too. What I will demonstrate right now is just running all this stuff in CI. And so this is configured for this repository through this special file. There's this directory.github/workflows, and then you can put all your GitHub Actions workflows in there. And in here, I have a bunch of configuration that I'll explain at a high level. And before I do so, let me actually just make a new repository on GitHub and push this so that you can see what the results look like. So I'm going to create repository on the missing semester organization. You can have it public, so if anybody wants to poke at it later, you can look around. And then I'm going to set up a new git remote. and push this. So this will be running in the background while I talk through this CI configuration. So in this case, this is just a single file. There are a couple components of this that might be interesting to look at. So you can run the CI script. You can instruct the CI service to run your script on a variety of events. So here I'm saying like whenever I push changes, whenever somebody makes a pull request, or on the schedule, and this is a particular syntax you can look up, it'll run these checks automatically. This last component can be helpful in terms of making sure that your code is compatible with all of its external dependencies. Like if one of the dependencies of your project makes a breaking change, then running your CI on a schedule will help you catch that. Like even though it's not really your fault, like somebody else caused the problem, you will need to find a way to fix it. So that's the set of events on which this runs. And then the script defines a bunch of jobs. All of this is in a special syntax. It's in a YAML file, which is the declarative configuration file. And yeah, you can look up the syntax in the GitHub documentation. And it's kind of analogous for any CI service you might use. I define a matrix of tests I want to run for a bunch of different Python versions. And then I have a bunch of different jobs. So I have this test job, I have a type checking job, and I have a formatting job. And if we look at any one of these closely, we can see like, okay, we can define the operating system on which this runs. And then GitHub Actions are composable and they can build on top of other actions. So there's some predefined things like I can check out the latest commit of my repo, install Python on the machine that's running the stuff, install Hatch, this Python project manager I was using to do things like Hatch format. And then finally, you can define basically a shell command to run. And if any of these return a non-zero return code, then the CI service says like, oh, something went wrong. That's a CI failure. And so here I'm running my format checker and my type checker, and I'm also running the tests on all the different Python versions. And so if I go over here and refresh this and look at the GitHub Actions tab in my repo, I can find that for the latest commit, the formatter and linter passed. So there's this green check mark, but the type checker failed. So it's, yeah, these are the detailed outputs of the type checker. And then you could iterate on this and you can say, oh, like stuff is failing, let me go fix it, test on my local machine, push it up to CI and ensure it works there, and iterate till everything is all good.
I mean, we mentioned those particularly useful pull requests from others.
Yes, John points out that this is particularly useful for pull requests from others. So oftentimes people contributing to your projects won't even do basic things like run the code formatter or run the type checker. And so this kind of forces it to run for them. And that information on whether the CI passes or not will actually show up attached to the pull request on GitHub. So it's available there at a glance. Closely related concept to continuous integration is something called continuous deployment. So many projects make use of the CI infrastructure to not only test code, but also to deploy it. So you can do things like if you have a binary software you're working on, you can actually run the compiler and produce builds for like all the different operating systems and automatically publish them online or things like that. You can automatically deploy applications to web services. We even use this in Missing Semester. So if you take a look at the repository for our course, you'll see that we use CI and GitHub Pages to automatically publish an updated version of our website whenever we git push to our lecture notes repo. So super handy tool there.
So continuous integration is automatically formatting files that is automatically formatting commits.
Yeah, so the question is, what is continuous integration? And really, it's a way to run code in the cloud when certain things happen with your repository. And you can do a variety of things in there. One of the most common things to do is to run all these code quality checks. So you can run a format check, you can run a linter check, you can run the tests. You can do things like run code coverage and actually upload that to a different service, something like CodeCov, where you can see like a hosted web UI where you can look at and monitor code coverage over time. But you can run pretty much any code you want in here. So you can like write your own script and run it. And there are other use cases you can come up with for continuous integration. Code quality is just one of the primary ones. Cool. And then one other closely related topic I'll talk about is command runners. So in this lecture, you're seeing me type out commands like hatch format and hatch test and stuff like that. And so how do those work? Hatch is a Python project manager, and it supports this pyproject.toml configuration file, and it also has a bunch of built-in things like hatch FMT is a built-in thing that uses the rough formatter and linter under the hood. And so it's a convenient way to run all the commands related to code quality without having to type out long invocations. But in certain projects, if you're not using a language-specific project manager, you might have to type out things like, maybe you want to directly, like manually call MyPy, and you might type out like MyPy --strict install types non-interactive source tests to like run the type checker over your code. And typing this out every time is tedious, right? You don't want to do that. And so there's also a notion of something called a command runner, which basically is just a list of, I can show you what that looks like. There's a command runner called just, J-U-S-T, and you can basically define these short aliases for longer commands. So again, here it's a little bit redundant because I'm using the Hatch project manager, which also supports this functionality. But if you were working in a project where you weren't using something like this, and you wanted to not have to type out long things like this string, instead you can do like just type check and just format and so on, and it will run the things defined in this just file here. So handy little tool. Cool. So any questions about command runners, or about continuous integration and continuous deployment, or code quality more broadly? All right, cool. So that's all I had to say about code quality. If people have to leave, feel free to go, but I'm going to take another 10 minutes to talk about regular expressions. This is a topic which we originally had in the development environments lecture and then moved around just because of time reasons. And it's a kind of cross-cutting topic, so I think it does fit in here as well. Basically, regular expressions, commonly abbreviated as regex, hopefully you've heard of these before. It's a language used to represent sets of strings, or analogously string patterns. And these regex patterns are commonly used in command line tools, where you can specify arguments where you give string patterns. I mean, even in this lecture, we were specifying a regex pattern to the AG tool to look for this pattern of pattern in our code. There are other command line tools that will use regex for things like if you have thousands of tests you've written for your program and you want to run some subset of them, these tools like Hatch Test will support an argument which will let you give a regex pattern where it'll run only the subset of tests that match that pattern. Other use cases of regex include things like in your IDE, you can search by regex pattern. So instead of searching for a concrete thing, look down here, like Hatch, I could search for, like, I want to find all, let's look at a different thing. Let's go to like utils.py. Let's say I want to find all numbers. I can search for \d \+ in Vim regex syntax. And we see highlighted here all the numbers in my code, right? And you can even do search and replace. So I can replace all the \d \+s with high, which is not very useful, but see, like all of these have been changed to high. So regex is really useful for search and replace as well. And so hopefully that motivates learning this like mini language used for describing sets of strings and describing replacements on matched strings. So let's talk a little bit more about regex syntax. I think throughout this course, like including in lecture 1 when we gave some examples of grep, all the way through to today's lecture where we have this example of AG, hopefully you have a little bit of intuition for like roughly what regex patterns look like and what they're used for. And we can go a little bit deeper on how to think about them. Some things to be aware of, like regular expressions are really a CS theory concept, and then they're implementations of regex in many different programming languages and tools. So like my Vim editor, which I have open on the left here, has an implementation of regex to search for things. AG, which I was using on the right here, has a regex implementation to do string pattern matching. What's a little bit annoying is that there are many different flavors of regex, like between different programming languages and libraries and tools and stuff like that. And the underlying concepts are the same, but there's some slight difference in surface syntax. So like with Vim, you saw on the left, I had to do \d \+. So I had a backslash for both of those special character classes or like special features in regex. But I think in AG, it's just like \d, and then I can do plus here to find all the digits. So like little variations like that. So it's like an annoying thing you have to deal with. But kind of the core functionality of regex is like pretty similar across tools. And these little differences, like either you'll memorize or look up when you need them. In the lecture notes, we've linked to a comprehensive guide on regex syntax, which I recommend just skimming through at some point. And then right now we'll walk you through some of the fundamental concepts. Another really useful tool, like hopefully, like, are we all good on the context, like where, in what situations we might want to use regex, such that we can focus just on the language and pattern matching itself? Because if we are, then I'll use this tool called regex101.com. There are many websites like this around, but they'll let you do things like write down a bunch of possible test strings and then write a regular expression here, and it'll show you which strings are matched by the regular expression being tested. You can also, using these tools, switch between different flavors of regex. So like Python regex varies a little bit from JavaScript regex, but you can try all the different ones using such a tool. So, was there a question?
What is this doing? I'm missing the regular expression test.
Yeah, so this up here is the regular expression. So I can do something like the \d\+ here. This is kind of like a regex debugger tool, so it'll explain it to you and let you evaluate this regex
Whether you okay.
against a bunch of strings.
As if that's your code.
Sorry, what?
As if the test string is your code that you
Yeah, or whatever you're trying to match, yeah. Like more abstractly, like regex is a language for describing sets of strings, and then here it's showing you which of these concrete strings match the expression provided up here. Cool. So yeah, that's what the setting is. That's what this regex 101 tool is doing for us. And so here in regex, certain characters just match literals. So like if I just type in a regex that's just the string ABC, it'll match the literal ABC. That's the most fundamental building block of regexes. And then some other little components to be aware of. There's something called regex character classes. And in square brackets, you can say, like, this should match any of the string ABC. So if I do ABC here, maybe I'll get rid of that. This pattern bracket, ABC close bracket, matches A or B or C. So this is saying any one of these characters. Now you can compose these. So if I do like hello and then bracket ABC, this will match the string hello A, hello B, but not hello D. You can also negate these with the caret character. So if you do open bracket caret, then it's like not any of these strings. So now I've inverted what I match. See, it matches hello A, hello B, doesn't match these two anymore, but it matches hello D. It'll also match like something, oh wait, it'll match hello, yeah, like hello F, for example.
Will it match hello, will it match like hello A, B, because A, B is not equal to A or B or C?
Yeah, so the question is, will it match hello AB? So we can just test that out. And no, it doesn't match because it starts matching from the left. And this HELLO matches up to here, but then the next character has to be something that's not one of these. So this does not satisfy not any of ABC.
So is that any single character?
Yeah, so in brackets, it's like any single character. You can also do ranges here, so you can do A through C or A through F. So you don't have to type out individual characters. Then there's some combinators like the alternation combinator. So you can say hello or world. So this will match hello. It'll match world, but not missing or semester. So this thing says either pattern on the left or right of this alternation operator. There's some more convenient ways to represent classes of digits, generally denoted with the escape character / followed by the like a mnemonic letter. So \D, for example, matches digits. So this will match 3 and 4, but not any of these words up here. There are other useful character classes like \W, which matches any word character, so not a digit. A really handy one is something called \B that matches word boundaries. So if you want to find all, say, like you want to find all the function definitions in your Python code, so you're looking for all the DEFs. Like maybe you're using the word DEF in other contexts. You might have like a def foo, but you might also have like a define, like maybe you have a string like hello, blah, blah, define. And you want to match this DEF, but not match this DEF. You can say, I'm looking for a word boundary. So this actually matches things in between characters if it's a word boundary. So it's not matching a character itself, followed by DEF, followed by a word boundary. And when I do this like boundary, DEF, boundary, and it matches this DEF, but not the DEF in define. There's some other handy combinators. You can group things together. So you can do something like hello or world like this. So combining this with the alternation character. Now this worked without the ors, but in certain cases you do need the grouping just due to the way operator precedence works. So you can use parentheses for that. And then I'll go through maybe just a couple other things. Dot matches any character. We saw we used backslash as a special character. So if you want to actually match a literal backslash, you have the pattern backslash backslash, which escapes the following backslash. And then kind of similar to the word boundary special escape, there is a caret character that's like, it matches the start of the line, and then dollar matches the end of the line. So this will match world, but won't match like hello world, hi. Because we have to have start of line, world, end of line. And then briefly going back to these groups we were talking about, these are not only for grouping and operator precedence, but they're also used as capturing groups. You see like pop-up that says capture group. So this lets us talk about regex search and replaces and actually refer back to subparts of the matched expression. So this can be useful in an IDE, for example, where like say I want to match all the numbers and actually replace them with like the number repeated. So like I want to replace the 15 with 1515 and the 0 with 00. Now this is a kind of wacky example. In practice, you can come up with more realistic things that make more sense. But let's demonstrate this. So we can match. So how do we do a digit? It's \d. I think I didn't introduce this particular one. There's a lot of details of regex that you can look up. So here I'm doing substitute. \d \plus. What the \plus does is it says one or more of whatever came before it. So now I'm matching one or more digit, and I can do slash. So that is in Vim, that's how you denote the end of the regex pattern, and now I have the replacement. So if I do hello, it'll show me like all of these things are being replaced with hello. But you can also refer back to a captured match by putting this in parentheses and then doing \, let's do, yeah, the escaping is different between different tools. So I think in Vim, the capture group needs to be escaped. So I have a \, open paren, \d, \plus, close paren, slash to end the regex pattern, and then \1 to refer to the first element of the capture group. So I can actually replace this with \1, and then /g to replace globally. And this is letting me preview the replacement. And when I hit enter, I see that like the 15 changed to a 1515 and so on. So these replacement patterns can be helpful in IDEs or in other contexts where you'll have a regex that includes capture groups and then a replacement pattern that refers back to elements of that capture group. This is also helpful in the context of programming languages. Like many times you'll be writing a program and it'll be handy to have some way to talk about patterns of strings. Like maybe you're trying to parse email addresses in a program or other things like that. You can use regex for some lightweight parsing. For really sophisticated languages, you shouldn't use regex because it's a kind of limited language. But for simple things, like say we're trying to parse a file where there's a bunch of dates in year, dash month, dash day format. So we have a bunch of strings like 2026-01-23, today's date. And say we want to parse out from here just the year. So we can do that using regex. So in Python, we can do, for example, re.match. R is making this a raw string, so it's a little bit less painful to type in all the escape characters. And I can say, okay, I want to match against \d, this brace for brace is saying 4 of the thing that comes before it. So I want to capture this, and then this is followed by 2 more digits, and then this is followed by 2 more digits. So to match that pattern in, yeah, say this example, for example, and maybe you'll have like a loop that does this over a whole bunch of strings or all the lines in your program or something like that. So I can go ahead and like bind this to M. And if I look at m.group1, this gives me the first capture group, and then I can go ahead and here, and if I want to define multiple capture groups, I can do something like this and extract out different components of this matched string. So this is helpful for things like, if you have, say, web server logs where you want to parse out like what IP addresses were hitting your web server, you can write a regex pattern for that, and then write a program that uses your programming language's regex library to filter out what you need. Or equivalently, use the same regex pattern into like grep to filter out what you need. So yeah, just as a recap, regexes are a really compact language for describing sets of strings. Regexes do have some limitations, and there's actually some like fancy CS theory stuff we link to in the lecture notes if you're interested, but basically you can't use regexes to do certain things. Like if you wanted to parse HTML, like the language of regexes is actually not powerful enough to do that correctly. And so in certain cases, you will need to reach for a more sophisticated parser, but for many string processing tasks, regexes are super handy. It's like a simple, succinct language to learn and way more lightweight than something like a full like context-free grammar parser.
Can you use regex inside of your code, not as a command line?
Yeah, so the question is, can you use regex inside your code? And the answer is absolutely. And actually, that's what we were doing here. Like I opened up a Python REPL and I was just typing in individual lines of Python code. But yeah, we could totally go to like this program and do like import RE and use the regex library in here. And in fact, like a lot of the programs we're looking at, like AG, for example, uses an external dependency that actually implements the regex library. Like they didn't cook up their own. It just uses the like one of the popular Rust regex libraries.
You put import RE.
Yeah, like in Python, it's called RE. In different languages, like I think in Rust, there's a popular third-party library, so it's not part of the standard library of Rust. Depends on programming language. Cool. So we did end up covering regexes in the class. Fantastic. And that is actually all we have for you today. So happy to stick around and answer any questions if anybody has questions on really the entirety of the contents of the course. And if there are no questions, we can wrap up. Also, if John wants to come up here, you can also take another mic and answer questions. Yes?
This is the end of the course, right?
Yes, this is indeed the end of the course.
Thanks a million.
Yeah, hope you enjoyed it.
Can we cycle back to doing the AI thing that I mentioned or not?
Sure, yeah.
If you have time to do that.
Yeah,
Which AI thing?
coverage.
Any of them, but how you use it to have more code coverage, and also how could you use it to say not just do code coverage, but test the different functionality of it. Like to actually do that in real time. Because I'm new to this, that'd be helpful to see how you implemented it. I don't know if that's
Yeah,
too much, but
so I guess the I don't know if this thing's on. Maybe not. Find out.
No.
Now it is.
Oh, perfect.
Ooh, yeah.
Nice.
Great. I have the power. So the question is basically, can you use AI, or can you show us how to use AI to
Show us.
like expand the test suite, get better coverage, and so on? We can show you some of this here. The thing, this also comes back to the discussion we had last lecture about like how much can AI actually do? Like, does it actually understand? And some of the things you'll find here is that you start out by it giving you really useful tests, but as you ask it to generate more and more, it will start to generate more useless ones unless you guide it well. And so it will not do it automatically for you, but if you guide it sufficiently, then you can get to like sort of collaboratively, you can get to a very good place.
is there a repository for good prompts that people have used?
I
Is
think there are tons of resources online. Some people have concrete examples. I think there are other situations where people commit prompts in the commit messages when they do AI-assisted coding. So there are various places where you can find prompts. But also, you can just be creative. These things are pretty intuitive.
Yeah, I mean, but one of the things to think about with these LLMs in particular is that they tend to be pretty good at following English instructions. Like, you don't need to write the prompts in a very specific way. You can sometimes squeeze a little bit more out of them if you know how to like make them focus on particular things, or use particular keywords, or those kinds of things. But usually that's for like the last couple of %. That's not for the majority of the usefulness. Yes, we now have
Yeah, we got to
100% coverage.
Yeah, there we go. Fantastic.
Can you look at the test it generated?
Yeah, so let's look at the tests. These functions in here are so simple that I think the tests are actually pretty decent for these functions. But it has like reasonably thorough tests, and we see it test like all the different like multiples of 3, 5, 15. So it hits all the cases of that FizzBuzz. It tests to see like, do we actually hit the exception and things like that. And if we look at the like coverage report, it is at 100% now. I also asked the AI to fix the bug as it went. So like it fixed some bugs, wrote some tests, reproduced the bugs, fixed the tests, and so on, and iterated till it reached a fixed point.
So I can watch that more slowly.
Yeah, it'll be in the video, but yeah, I had a short like couple sentence prompt for it.
First of all, thanks a lot. Really great.
Yeah.
Well, missing semester, more than it. Probably obvious question, but why not write a test in the code itself? Why have that separate file? What's the logic, the fundamental principle behind it?
I wouldn't say it's a fundamental principle. Like, for example, in Rust, it's very common to write unit tests in the same file as the functions that have them. And this sort of depends on the language and the conventions, but also the kind of test. So usually, at least in Rust, the unit tests tend to be fairly small. And so it's reasonable to have them in the same file as the functions you're testing. Once you start writing more complex integration tests, then Rust has a separate mechanism for writing them in separate files, just like Python does here. I don't know whether in Python you can also write tests in line.
Yeah, there's a thing called doc tests.
Okay, yeah. So you have a similar thing in Python where you can also write them in line with the rest of the code. So it sort of depends on whether it feels right for the test to be small and next to the function, or whether it's you're writing sufficiently advanced or complex set of tests that you want them to be split out. For compiled languages, this distinction can also matter. So if you put your unit tests in the same file as your code, you can actually end up having to recompile your whole project because you changed the tests, right? Because you ended up changing the source file that contained, like the tracking is only based on the file, not based on which part of the file did you modify. Cool. Yeah, go ahead.
And how do you test? There's a lot of API calls going back and forth nowadays. Is the testing exactly the same, or do you apply different methods there?
Yeah, so the question is, if you have API calls in the program you're writing, like how do you test those? What does the methodology look like? And there are a couple different methods people use. One concept we didn't cover today is something called mocking. So you can basically build out mock versions of dependencies that your application, your functions use, and inject those when the tests are running. So for example, if there's an API client, like say you're building an AI agent and there's an OpenAI API client that's calling out to the OpenAI API, you can instead mock that client and basically fake return values for specific arguments for the purpose of individual tests.
Mock that client?
Yeah.
What's that mean?
So mocking is when you implement the API of something, but you have your own implementation behind that API. So for example, you might write an implementation of the API of, I don't know, the YouTube API, right? Google documents a bunch of APIs for YouTube, and let's say you wrote an application that wants to interact with YouTube. Well, you could write a program that has the same API as the real YouTube API, but behind the scenes, it's just like some very simple implementation you wrote that you can use as part of your test suite. And so when you're testing with a mock, you would run your program but point it at that one instead of the real YouTube API, and that way you have much tighter control over what happens behind the scenes. You can like tell it to return an error or whatever you might want it to do. And you can also have, like, you can run it without having an internet connection. You can do a bunch more things because you control the implementation.
There's another technique people sometimes use, which actually runs the tests against the live API once and records all network communications such that it can be replayed for future tests. So for Python, for example, there's a library called, I think, PyTest VCR that does this. Also, you can just run tests against a live API. Like, that is the thing people do. There are upsides and downsides to that.
You quickly said where to find different prompts.
Mm-hmm.
So you're not going to find a place that has prompts. There's no repository of like all the prompts, but
I find it really useful to.
so you'll find that there are a lot of articles online on how to write good prompts. There are good YouTube videos and articles and the like for coding, but
There's
also
a
just
lot
in
of
general.
first-party content. Like OpenAI and Anthropic and others like want you to be good at writing prompts so you can use their products and services. So they've written like pretty good guides on how to use these tools, like Anthropic and OpenAI and other labs that develop these AI models.
Yeah, and in general, you'll find this more in the sense of guidance for writing good prompts rather than example prompts. That's less common because the examples tend to be very tied to the particular code base and what you want to do. If you want example prompts, then I think the best you could find is either someone who has like recorded themselves on YouTube or something, having a session with an agent trying to make some change, or you could also like just search around for like experience stories people have on, Blue Sky or Mastodon or LinkedIn for that matter, or Twitter. Like look around for people who sort of share their experience. But I think your hit rate will be pretty low there. The guidance articles tend to be better. Cool. Thank you. And see you all in hopefully less than maybe 6 years. We'll see.